Hi, good morning, everyone. I'm so happy today that I could have such a lovely neat place to give this talk. Well, but the first thing I want to say is this room technically is not clean at all. Everything here, no matter what you're watching, what you're touching, and even what you're breathing in this room, is contaminated by bacteria. But no worry, we human beings can still live a long, long life and prosper even though we are surrounded by all kinds of bacteria. That is because we have our own well-designed defensive systems. In our body, we have a group of guard cells, which is called neutrophils. Those cells can stay in our circulation, and once we get injury, they will respond very quickly, move to the wound, and kill the bacteria. My thesis is on the mechanisms how these neutrophils know where the wound is, how they move from our circulation to the wound, and how they kill the bacteria. I'm starting a small molecule which is called BAM32 in this whole process. In my study, I use a strong bacterial peptide to challenge the normal mice. In most cases, the normal mice shows a very good defense. They can generate a high number of neutrophils in their wound, and those neutrophils can produce reactive oxygen species, which is very harmful to the bacteria. Then I use the same bacterial peptide to challenge the mice without BAM32. Those mice without BAM32 can generate an even higher number of neutrophils. At first, I was very happy about this finding because a higher number of neutrophils usually means a better defense. However, things will never be that easy. As I push forward my studies, I further found that although those mice without BAM32 can generate a higher number of neutrophils, those neutrophils cannot produce reactive oxygen species. That means those neutrophils can reach the wound, but they cannot kill the bacteria. They do not have the spares, which is a really bad defense. In my thesis, I further illustrated why this molecular BAM32 is so important in this whole process and how it is involved in conducting the cell signals. All in all, I have been trying to understand for our human beings how to avoid a bad defense, how to maintain a good defense, and how to achieve an even better defense. Thank you, that's all.